students, I am Dilipudani, Assistant Professor at LJ Institute of Engineering and Technology. Today in sequence and series, I will teach you new topic, that is the comparison test, the limit comparison test. So let's start. So first of all, we will see what is direct comparison test. Suppose sigma un and sigma vn are two series of positive terms. First, if sigma vn is convergent and un is less than or equals to vn for all n, then sigma un is also convergent. Second one, if sigma vn is divergent and un is greater than or equals to vn for all n, then sigma un is also divergent. Now we will see limit form of the comparison test. Suppose that sigma un and sigma vn are the series with positive terms. If limit n tends to infinite, un upon vn equals to L, where L is a finite and non-zero value, then both series either converge or diverge together. That is, if sigma vn is convergent, then sigma un is convergent and vice versa. Similarly, sigma vn is divergent, then sigma un is divergent and vice versa. So this is the limit form of comparison test. Now this is an important point. For comparison test, we have to define some series sigma vn whose convergence or divergence is known to us. In most of the cases, we are going to use the following tests. Number one, P series test. The P series, sigma n is from 1 to infinite, 1 upon n is to P, converges for P greater than 1 and diverges for P less than or equals to 1. Number 2, geometric series test. The geometric series, sigma n is from 1 to infinite, ar raised to n minus 1, where a is not equal to 0, converges if mod r is less than 1 and diverges for mod r is greater than or equals to 1. Now we will see examples related to this. Determine whether the series sigma 2 plus 3 cos n upon n cube converges or diverges. Here un, that is equals to 2 plus 3 cos n upon n cube, but we know that cos n is less than or equals to n. So multiplying this inequality by 3, we have 3 cos n less than or equals to 3. Adding 2, we have 2 plus 3 cos n, that is less than or equals to 3 plus 2, which is 5. Now dividing by n cube, we have 2 plus 3 cos n upon n cube, that is less than or equals to 5 upon n cube. Suppose un equals to 2 plus 3 cos n upon n cube and vn equals to 1 upon n cube. Therefore un is less than or equals to vn. You can see from this one, right? This is un and this is vn. Vn is 1 upon n cube, so definitely this is going to be less than 1 upon n cube. So we have un is less than or equals to vn. Since this value, which is 3, greater than 1, therefore sigma vn is convergent by P series test. Therefore sigma un is convergent by direct comparison test. Now discuss the convergence of the series sigma n equals to 1 to infinite 2n plus 1 upon n plus 1 the whole square. Here un equals to 2n plus 1 upon n plus 1 the whole square. Taking n common from the numerator, so we have n into bracket 2 plus 1 upon n, upon taking n common, so it will become n square into bracket 1 plus 1 upon n the whole square Now 1 time n will cancel out, so we have 2 plus 1 upon n into bracket 1 plus 1 upon n the whole square. So let Vn equals to 1 upon n, and by using limit comparison test, that is limit n tends to infinite un upon Vn, that is equals to limit n tends to infinite. Now this is directly we have written un upon Vn. If we will divide this un by Vn 1 upon n, so this n and this n will cancel out, so this is the result. Now as n tends to infinite, 1 upon n tends to 0, so we have 2 plus 0 in the numerator and 1 plus 0 in the denominator, so the result is 2, which is a finite and non-zero value. Now sigma Vn equals to sigma 1 upon n is a p series with p equals to 1. The series sigma 1 upon n is divergent, because for p greater than 1 the p series is convergent, and for p less than or equals to 1 it is divergent. So sigma 1 upon n is divergent. So by limit comparison test, sigma un is divergent. Now we will see this example. Test the convergence of the series 1 upon 1 into 2 into 3 plus 3 upon 2 into 3 into 4 plus 5 upon 3 into 4 into 5 plus dash dash dash. Here un equals to, from the numerator terms 1, 3, 5 and so on, the difference between two consecutive terms is same, that is 3 minus 1 is 2, 5 minus 3 is 2. And its nth term is given by the formula a plus n minus 1d. A is 1 and d is 2, so 1 plus n minus 1 into 2. So after simplification you will get 2n minus 1. Now for this sequence 1, 2, 3 and so on, its nth term will be n. Now for this sequence 2, 3, 4 and so on, its nth term will be n plus 1. Now finally for this sequence 3, 4, 5 and so on, its nth term will be n plus 2. Now taking n common from the numerator, so we have 2 minus 1 upon n. Now taking n common from n plus 1 and n common from n plus 2, so it will become n cubed into bracket 1 plus 1 upon n into bracket 1 plus 2 upon n. One time n will cancel out, so we have 2 minus 1 upon n square into bracket 1 plus 1 upon n into bracket 1 plus 2 upon n. Now let Vn equals to 1 upon n square. Now by using limit comparison test, limit n tends to infinite un upon Vn, this is equals to limit n tends to infinite. Now this is un and this is Vn. If you will divide this un by this Vn, so n square will cancel out, and after simplification you will be having this result. Now as n tends to infinite, then what will be the result of this expression? So as n tends to infinite, 1 upon n tends to 0, so 2 plus 0 is 2, 1 upon n tends to 0 as n tends to infinite, 2 upon n tends to 0 as n tends to infinite, so it is 1 plus 0, 1 plus 0, and so the result is 2 upon 1 into 1, which is 2, and which is finite and non-zero value. Now sigma Vn, that is equals to sigma 1 upon n square, is a p series with p equals to 2 and which is greater than 1. Therefore the series sigma 1 upon n square is convergent, as p series tests say that the given series is convergent for p greater than 1 and it is divergent for p less than or equals to 1. Therefore, by limit comparison test, sigma un is convergent. Now we will see this example. Test the convergence of the series sigma n equals to 1 to infinite sine 1 upon n. So here is the solution. Here un equals to sine 1 upon n. Maclaurin series of sine x is sin x equals to x minus x cube by 3 factorial plus x raised to 5 by 5 factorial minus x raised to 7 by 7 factorial and so on. But we have to find out sin 1 upon n. So replacing x by 1 upon n in the Maclaurin series of sin x. So we have sin 1 upon n, that is equals to replacing x by 1 upon n, so it is 1 upon n. Then after minus 1 upon 3 factorial, x raised to 3, so it will become 1 upon n raised to 3 plus 1 upon 5 factorial, 1 upon n raised to 5 minus 1 upon 7 factorial, 1 upon n raised to 5 and so on. Now taking 1 upon n common, so into bracket we have 1 minus 1 upon 3 factorial n square plus 1 upon 5 factorial n raised to 4 minus 1 upon 7 factorial n raised to 6 and so on. Now let Vn equals to 1 upon n, and by using limit comparison test, limit n tends to infinite un over Vn, that is equals to limit n tends to infinite and n will cancel out. So we have this result, that is 1 minus 1 upon 3 factorial n square plus 1 upon 5 factorial n raised to 4 minus 1 upon 7 factorial n raised to 6 and so on. Now as n tends to infinite, these all term tends to 0. So the result is 1, which is finite and non-zero value. Now sigma Vn equals to sigma 1 upon n is a P series with P equals to 1. Therefore the series sigma 1 upon n is divergent. By limit comparison test, sigma un is divergent. Now we will see this example. Test the convergence of the series sigma n equals to 1 to infinite 1 upon 3 raised to n minus 1. So here is the solution. Here un equals to 1 upon 3 raised to n minus 1 and this is equals to 1 upon taking 3 raised to n common. So into bracket we have 1 minus 1 upon 3 raised to n. Let Vn equals to 1 upon 3 raised to n, and by using limit comparison test, limit n tends to infinite un upon Vn, this is equals to limit n tends to infinite, this is un and this is Vn. So 3 raised to n, 3 raised to n will cancel out. And this is equals to limit n tends to infinite 1 upon 1 minus 1 upon 3 raised to n. Now as n tends to infinite, 3 raised to infinite tends to infinite and 1 upon infinite is 0. So 1 minus 0 is 1 and 1 upon 1 is 1. So which is a finite and non-zero value. Since this limit exists and sigma 1 upon 3 raised to n is a geometric series with ratio r equals to 1 upon 3. Therefore mod r is less than 1. Therefore the series sigma 1 upon 3 raised to n converges. Therefore by limit comparison test, sigma n is from 1 to infinite, 1 upon 3 raised to n minus 1 also converges. So in today's lecture we have discussed direct comparison test and limit comparison test, and we have seen different examples related to this topic. Thank you for watching this video. I will see you in the next lecture.